Hello, this is Olivier Valois from Hewlett-Packard Enterprise. I am looking after the Pensando SmartNIC cards, also known as HPE SmartIO. These cards are next generation networking cards with embedded hardware acceleration capabilities. For Pensando itself, the hardware acceleration is for things like telemetry, like encryption, like firewalling, for instance. So I would like to show you a demonstration of the telemetry capabilities in this short video. So let me close my video now and share my screen with the actual demo. So the demo environment is pretty simple. You have an ESX1 with a networking card, a DSC25. So this is a 10/25 gigabit networking card, Pensando with 2 ports. That ESX has 2 VMs, Linux, with IP address at the end 71 and 73. And then you have another ESX with also 2 VMs with IP addresses 70 and 72. These VMs are exchanging traffic permanently with IPERF on some well-known ports like HTTP and HTTPS, for instance. I'm going to log in on Windows 1 and Windows 2. These are my, let's say, servers from where I'm demonstrating most of the elements. So this is 10.6.48.60, the Windows server I was talking about. Let me show you the Pensando console software called PSM. So that's the console from where we can manage and configure all the networking cards from Pensando. So in this case here, we have only 2 because we have 2 servers, 2 ESX servers. We have 46 sessions currently active going through these cards. These sessions are actually my IPERF sessions. And then we have some basic, let's say, information regarding the top 5 active hosts and top 5 active workloads, let's say the health of the cluster. So the cluster is the PSM cluster made of 3 virtual machines. So that's the very basic information in terms of telemetry. If you want to know more, we click on DSC. We have the list of the DSCs here, so we only have 2. I can click on one. I've got some information regarding the card itself, but also information regarding the networking ports. So ports 1 and 2 are the uplinks. So, and ports, let me scroll down. Ports 69 and 70 are the ports connected to the PCI bus. So I can expand that view here by clicking here. And I've got more information in terms of bandwidth for each port. I can scroll down also so that you can see PF70. So we have the different ports, the bandwidth, the total traffic in terms of bytes and packets, and often more interesting information regarding the drops. I also have some information directly here on metrics. So I have predefined metrics configured for this card so that I know, let's say, very easily how many packets, how many bytes, how many drops we have on this on that card. On what else? The live sessions is also interesting. I can click on DSC, get DSC live sessions, and we have a view of the different sessions that are currently going through that card. We recognize here the IP address is 71 with 70 on port 8080. Here, this is HTTP, HTTPS, and so on. And we recognize 70, 72, 71, 73. These are my 4 virtual machines, Linux. So if you want to know more, we can have can go to metrics, a metrics view. That's where you can define your own metrics or your own graphs. I have configured these ones, for instance, for the time being. So let me show you how to do one. Let's remove this one. And let's remove this one as well. Okay, so you might notice, by the way, that you can select to have a view of the past day, but also past hour, past week, if you like. And you can define your own, let's say, timing in terms of when you want to start and when you want to stop the graph. You can create graphs by clicking create chart. And for here, you have a lot of different, let's say, parameters that you can graph. For instance, for the session, you have the ESP sessions, you have ICMP sessions, and so on. So you have a full list of the stuff that you can graph. Forwarding drops, logical interface, uplink interface. You see plenty of different things that you can graph. So let me graph this one for the to know what are the size of the packets on an interface. So I specify the different parameters in terms of size. I select one interface. Let's take the first one, save chart. And I have at the very bottom, hopefully, my graph, which tells me the repartition in terms of packet size on that specific networking card I have selected. And I have, so this is a view of past week. And of course, if I have a problem that I want to troubleshoot, maybe that occurred recently, I can check the past hour. Okay. Next, I have also a new tool that came with the latest version. It's called Diagnostics, where I can specify, so it's an end-to-end troubleshooting tool, where I can specify, for instance, one IP address source, one IP address destination, a protocol. I don't really need a protocol, and which gives me basically a graphical view of let's say the path for a packet sent from 72 going to 73. So it's connected on so the 72, for instance, is connected on micro-segmentation VLAN 1284. It is behind that card here, Pen DSC ESX102. It goes through the network, and then it goes to networking card Pen DSC1 ESX1, and it is the target virtual machine is connected on micro-segmentation VLAN 1121. Then we have some information regarding the DSC health, DSC profile. So the DSC is the networking card. You also have the ability to get my source DSC live sessions by destination live sessions. So to know what's going on the basically on that card, or what's going on that card live when I'm asking for it. I also have some interesting elements here. I can verify if this packet, let's say between 72 and 73, or this flow is going through a firewalling rule. And it actually does. It goes through this security policy called test, and my packet is actually going through this first rule, which is permit any. I also have a view of if there is any IPsec rule involved. And yes, there is one called IPsec policy, ICMP_MySQL01, where I am encrypting the traffic between 73 to 72 and vice versa for ICMP traffic only. So that, by the way, shows you that you can decide to encrypt one application and between IP addresses or between hosts, between VMs, but not all the traffic. So you have some kind of a selective option in terms of encryption. You can decide to encrypt all, or you can decide to encrypt just one application. And you also have a matrix view, which is with predefined lots of different graphs that are interesting to know what's going on the different interfaces involved by this traffic from the source 72 to the destination 73. You can decide to unselect some predefined graphs if you want. Okay, so now what else do we have? We have the ability to do flow export. Flow export is nothing more than an IPFIX agent embedded in the networking cards. So every networking card is basically now taking, let's say, some notes of all the traffic, all the packets, because I have specified here for the export packet rule, source any, destination any, protocol any. And I'm sending that to this guy here, 10.6.48.60 on UDP port 9996. That's where my NetFlow collector or my IPFIX collector is actually running, and that's what I see here. I have to reload this one. Oh no, sorry, it's this one. Oh, it works. Yeah, so this is my IPFIX collector, where basically I'm displaying statistics in terms of applications. So these are my HTTP, HTTPS, MySQL ports that I'm exchanging through the IPERF sessions, which IP addresses are the source, the top talking, let's say, top destination, the repartition in terms of protocol. So it's more TCP than UDP, then you have the rest, which is probably ICMP. What else? And then we have the conversation, so we know who is talking to whom on which port. Okay, so that's IPFIX. Okay, so let's verify now another tool that we have, which is called mirror sessions. Mirror sessions, that's the ability to copy some flows to a destination where I have typically some kind of a network analyzer. In my example, I'm using Wireshark. So the rule is to mirror traffic looks like this. You can specify basically what are the packets that you want to mirror. So in my case, I am copying the ICMP flows between 73 and 72, between 73 and 71, and between 73 and 70. That's about it. And yes, I'm sending that to that guy here, 10.6.48.60, where I have a Wireshark device running. Okay. And I have another one here. That's another type of rule where I specify that I want to copy everything that is going through my uplink. So this is, I'm using this one to prove that I am actually encrypting traffic. So the first one is called before encryption. That's because I'm going to mirror the packet before it is encrypted. And after encryption, I mirror the same packet, but after it is encrypted. So the first one gives me the ability to prove that I am encrypting. And the second one, before encryption, gives me the ability to see traffic before it is encrypted. So that avoids the typical problem that we have with encryption, where we are losing visibility of the traffic with this kind of solution here, where we encrypt directly in the networking card with an embedded ERSPAN agent or traffic mirroring agent directly in the card. We have the ability to decide that we want to copy the traffic before and just after, or let's say before it is encrypted and just after it is de-encrypted, so that we have the traffic in clear text. Okay, so let me show you that. I have my Wireshark running right now. Continue without saving. I'm going to send some pings. Oops. So I am right now on one of these Linux platforms. You can recognize 48.73, that's the IP address. I'm pinging 72, and I see ESP traffic. So let me stop it now. So let me stop my ping as well. Why do we have that, by the way? That's simply because if you remember, I shouldn't have closed. I have to come back to my PSM view. I have in the security configuration, I have an IPsec policy configured where I configure ICMP traffic between 73 and 72, 73 and 71, 73 and 70. By the way, I will just remove that one. Delete. I have to save the policy just to show you that I am encrypting some pings and not all of them. Save policy. Okay, so let's go back to my ping now. Oops. 72. Continue. So we have the ESP traffic for 73 to 72. And if I ping 70, I don't see anything. That's normal. That's normal because I am not encrypting that traffic. Now, let me ping 71. I think I was encrypting through 71. Or maybe I was not. What else do we have? I wanted to show you, yes, that I can see the traffic in clear mode, in clear text. So let me ping 72. So I've got ESP here. We see it's moving. So now let's take ICMP as a filter. And I also see my ping between 72 and 73, and this time in clear text. Okay. Now let's take a look at the very last let's say troubleshoot element that we have, which is called firewall logs. So I can decide to log the rules, or say the traffic that is going through the rules of my firewall. I can also decide to implement something called firewall log export policy. It's here. So in my example here, I'm logging all the logs to port 9001 to this IP address 48.61. That's where I have Splunk running, which shows me the traffic that is going through the firewall rules. And I also, by the way, here, a deny logs, reject logs rule. Let me cancel this one. Oh, let's open this one. And I'm sending that to port UDP 514. So that's typically a Syslog server that I have running on my host 48.61. So let me show you that now. So I have to go to the other RDP session. So 10.6.48.61, that's my Splunk server, and we recognize the IP addresses 10.6.48.73, 71, 70, the different the destination IPs as well, and the number of packets, and also the repartition of the different ports, and we recognize DNS, we recognize HTTP, 443 HTTPS, 8080, that's kind of an HTTP as well. Okay, so that is what is coming from my firewall log export policy. And I also have a Syslog server here running. So let me now block traffic and show you that is, it's not receiving anything now because if you remember, 10.6. If you remember, my log, it's for deny and reject only. So let me now block some traffic in my security policy here. I will block traffic. I will put this rule here first. It's source IP any to destination IP 72 or 73. Let's put that in rule number 1. So before the permit IP any save policy, let me do a ping. But there is a ping already running up, and it should generate a syslog message if everything works correctly. And yes, here we go. We have my syslog message that is coming to that 61 Syslog server, where we recognize source address 73, destination address 72, and that was ICMP traffic, and it was a deny rule. Okay, so that concludes basically my video for now. That was basically all the troubleshooting, telemetry capabilities that we have with the Pensando PSM tool and the Pensando DSC cards. So lots of very cool tools that help troubleshoot what's going on the network, including, for instance, the ability to watch traffic which is encrypted, but to watch it before it is encrypted, so that we have the clear text, let's say, or the packet in clear mode before it is actually encrypted by the card. We have an IPFIX agent that can log everything that you want. You also have the ability to go through different metrics of the card, so plenty of different parameters that are typically inaccessible now on traditional cards, or you can have access to also some information regarding the PCI bus itself, which is typically, again, a zone which is completely black, let's say invisible now with traditional cards. With that, if you want to get more information, don't hesitate to contact me, olivier.valois@hpe.com, olivier.vallois@hpe.com. Thank you very much.